All, Vinod here from Entrance Engineering Academy. Before going into the video, I just want to say a few things about Entrance Engineering Academy. So, EEA is an online gate preparation portal, and we offer full course for GATE ME and XE. In addition to that, subject courses are also available for ME, XE, CE, and PI. Engineering mathematics course is available for all stream, and in addition to that, we offer online test series for GATE ME and XE also. So this is our website. You can just check out so that you will get to know more about us. And in addition, we have our own Android app and also iOS app, and you can just go through that also to know more about our courses. Okay. And this is our last year, that is GATE 2021 result from XE. And now let us proceed to the video. And this video is taken from online video course of Endurance Engineering Academy. So now let us understand center of gravity, center of mass, and centroid. Basically, the difference between these three, okay, there is center of gravity, center of mass, and centroid, is not very clear among many of the GATE aspirants. Okay, so by going through these videos which I'm going to do, the videos related to center of gravity, center of mass, and centroid, I can guarantee you that you will understand the clear difference between these three words. Even though these three words are used interchangeably, but there is something which differs in each. Okay, what is that we will understand. Okay, so we will start with center of gravity first. Now, for understanding the center of gravity, you need to have a basic idea about coplanar parallel force system, which we discussed initially. Then the last few videos we discussed about center of parallel forces. And now we are starting with center of gravity. So without a center of parallel forces, it will be difficult for you to understand this. Okay, right. So now let us consider there is a plate. You consider that this plate is massless. Okay, so this is a plate. Okay, this is a plate. This full plate is a massless. And now in this massless plate, I'm attaching 6 masses. Okay, mass M1. You can just consider something like a massless plate where I'm attaching coins. Okay, so one coin here, one coin here, one coin, one coin, one coin, one coin. I'm just pasting the coins, and mass of the coins are different. Okay, so let mass of the first coin be M1, mass of the second coin be M2, and M3, M4, M5, and M6. And I'm taking gravitational force also different, because we will just do in a general way. Later we will see whether G will be constant or not. In general, G will be constant. That is what we will assume in the surface of the like in the sea level. We will be assuming G is constant. But if height varies, then G will also vary, right? In Earth, we will have different G. In Moon, we will have different G. Even in Earth itself, at some height, I will be having different G. At some other height, at the top of the hill, I will be having different G. At center of the Earth, we will have different G. So in general, it is general. So generally, I am assuming there are different Gs. If it is same, you can take G1 is equal to G2 is equal to G3 is equal to G4 is equal to G5 is equal to G6. All are same, and you can take it as G. Okay, right. Now, as we know that all these masses will be pulled towards the ground. Okay, so from the knowledge of free body diagram, all these masses will be pulled towards the ground, and the ground in turn, these masses will offer equal and opposite forces which pulls the ground up. Okay, all these things we seen already, and now we are concentrating only on these masses, right? So I'm not worrying about the ground, I'm not worrying about the earth, I'm concentrating only on these masses. So these masses are subjected to forces, gravitational force, right? These are the gravitational forces, and that will be acting downwards, that is ground. Okay, so if suppose there is a ground here, earth here, this earth will pull, okay, each and every mass, and that value will be equal to that mass into acceleration due to gravity. Okay, now listen, let us consider, first concentrate on this diagram. Okay, let us consider a person who is sitting here. Okay, let this be origin. Okay, I'm just assuming the coordinate system x-axis, y-axis. I am assuming that there is a person who is sitting here. Okay, who is sitting here or who is standing here. Let the person be A. Okay, and for this person, when he sees, okay, when he sees this object, how will be the forces? Obviously 1, 2, 3, 4, all the forces are acting downward. That is what he will feel. Okay, now listen. What are all these types of forces? First of all, these are coplanar force, coplanar because they are lying in the same plane, and they are parallel, right? This M1 G1 is parallel to M6 G6. Similarly, all these forces, okay, all these forces are parallel to each other. Okay, since all these forces are parallel to each other, how to find out the resultant? Resultant can be determined by simply by summing it up, right? By summing it up, and the direction will be, since all are in the direction which is facing downward, my resultant will also be in downward direction. And how to determine the line of action? Line of action can be determined by using Varignon's theorem, and you can find out that. Okay, let us assume that this is my resultant. Okay, it is passing through some point. It is passing through some point here, and this is my resultant. And what will be the value of the resultant? Simply summation of all this, right? Because all forces are acting down. If I simply add it, I'll be getting the resultant. So M1 G1 plus M2 G2 plus M3 G3 plus M4 G4 plus M5 G5 plus M6 G6. Okay, listen carefully. So this is my resultant and it is passing through some point. Okay, so we can determine the magnitude by just summing it up, and the direction, we know all forces are facing down, so resultant will also face down. Line of action can be determined by Varignon's theorem. Now what I'm doing, I taken one point here, right? I taken one person who is sitting at origin. I'm going to take another person who is going to sit at this point. Okay, sit at this point. Let me mark that point to be C. Okay, at the center. Okay, right. Now listen carefully. Fine. Now what I'm doing, I'm just rotating this. How I'm rotating? Just simply 90 degree. Okay, so if it is like this, I'm just rotating like this. Okay, so initially it was like this, right? I'm just rotating like this. And if I rotate it by 90 degree, I'm getting that. Okay, what will happen? This one, as I'm rotating by 90 degree, this one will reach here. Okay, so 1 which is present here will reach here. And similarly 2, as I am rotating, 2 which is present here, it will reach here. Okay, and the 3 which is here, it will reach here. Okay, so as you could see, I'm just rotating, you could easily observe it. Okay, as I'm rotating, this 1, 2, 3 has reached 1, 2, 3 here. And similarly 4, 5, 6 has reached 4, 5, 6 here. Okay, so I will just show you the line. This line, this resultant which was like this, just imagine this line. Okay, just imagine this line. How I'm just showing you how I'm rotating. Okay, I'm rotating it in this direction so that this line reaches like this. Okay, this line reaches like this. Now this person who is sitting at the center, right? The person who is sitting at the point C, I'll just take that. How he will be now? He will be like this, right? Okay, fine. Instead of being like this, he will turn like that. Okay, now, and what will happen to this person? He is not going to change. That is my reference origin. He will be simply like this only. Okay, this is person A, this is person B, this point I'm taking as C. Now, if I ask to this person, whether the position of masses changed or not, if I ask to this person what he will say? Obviously, he will say yes, mass position has changed, because initially for him mass was here, but now rotated, right? Initially for him, M1 was here, but now M1 has reached this place. And similarly, initially for him, M2 was somewhere here, okay, somewhere here, but now it is reached here. And similarly, initially for him, mass M3 was here, but now for the new, after rotating it by 90 degree, it reached this place. Similarly, all the masses has changed its position for this person who is observing from origin, outside of that body. But for the person who is sitting inside the body, who is sitting at the point C, okay, so who is sitting at the point C, what will be the observation which he is going to make? What is the observation which he is going to make? He is sitting here. Initially, you just imagine that I am the person who is sitting at point C. For me, top left, the mass was M1. Okay, left side mass was M2. Bottom left it is M3. Okay, and bottom right it is M4. Right it is M5, and top right it is M6. Now, same person is also rotated, right? Now, for him, top left still it is M1, left side still it is M2, because for him, like, I'm not like this now, I'm like this now. Okay, so for him, left side it is 2 only. For him, bottom left it is M3 only. For him, bottom right it is M4 only, right it is M5 only, and top right it is M6 only. For him, the position has not changed. Position of the mass has not changed. I hope you are understanding, right? For him, the position is not changed. But what has changed? What has changed? For him, initially, the forces, okay, position of masses has not changed for him. For him, the position of masses has not changed. But initially, the forces, that is gravitational force, which is acting at 1, 2, 3, 4, 5, 6, all the gravitational forces, for him, with respect to him, I'm sitting here, I'm just sitting at the point C. For him, at all the points, all 6 points, all the forces are acting down. Okay, acting down, that is towards its leg, okay, towards the direction where his leg was there, okay, towards the direction where his leg was there. But now what happened? All the forces are not facing towards his leg. Initially, towards the direction of his leg, all the forces are faced. But now, to left side of him, okay, see, the position of the force has not changed. Position is not changed. Position remains same. Okay, position is not changed. But the force orientation has changed. Initially, let me show you. Initially, the force was like this. Am I right? All the forces are like this, right? His leg was pointing towards this direction, so all the forces are this direction. But now, all the forces are in this direction for this person. Okay, I'm not talking about this person now. Let us forget him. The person who is sitting outside, for him, the position itself changed. The person who is sitting outside, for him, the position itself changed. So forget about him. The person who is sitting inside, position has not changed, but the orientation of the forces. Initially, it is oriented differently. Now it is oriented differently. So orientation is changed, but the position is not changed. From this, what you can say? If you have understood center of parallel forces properly, you can easily answer. What center of parallel force is saying? If I take number of forces, whatever may number of force you take, the resultant, I will be getting some resultant, right? If you change the orientation of these two forces, P and Q, you take any number of force, not an issue. I'm just showing you an example, two force. If you change the orientation of this P and Q, then this resultant will also change its orientation. Resultant also will change its orientation, but it always pass through only one point. That point is center of parallel forces. So if there are n number of parallel force, even though you change the orientation of parallel force, I explained that in the last videos, right, in the center of parallel force. So you change the orientation of the parallel force. If you change the orientation of parallel force, orientation of resultant will vary. Okay, so resultant will also get oriented. But the point through which the resultant is passing, okay, if P is oriented like this and Q is oriented like this, then R will also orient like this. But the point through which it is passing, that will not vary. So what I can say here. And one more point, there also the position of P and Q has not changed, right? Position of P and Q still same only I'm changing the orientation. Here also, with respect to this person, position is not changed. M1 is still here, M2 is still here, M3 is here, M4 is here, M5 is here, M6 is here. But initially for him, the orientation was like this. Okay, and he got, this is the point through which, resultant has passed. Now, only orientation has changed. Now, all the forces are, still it is pointing towards the ground only. But with respect to this person, I'm taking this person as my reference. With respect to this person, it has changed its orientation. Now it is acting left side. Okay, just imagine he's sleeping like this. Okay, so to its left side, all the forces has changed its direction, changed its orientation. Okay, so what will happen to the resultant? The resultant will still pass through the same point C. Okay, and how it is going to be? Something like this. So resultant still it is M1 G1 plus M2 G2 Mn Gn. I hope you are understanding the fact here, right? So this point, okay, this point through which the resultant of, understand carefully, this point C or point C, this point through which resultant of gravitational forces. What are these forces? These forces are gravitational forces or force due to gravitational effect. Okay, initially this point is called the center of parallel forces because it is just some force, some parallel force. But now these forces are coming into play because of gravitation. So the point through which resultant of the gravitational force, okay, you take you take the force which is due to gravitational force pass through, okay, so the point through which resultant of gravitational forces due to gravitational effect pass through, irrespective of its orientation. With respect to this person, all are oriented down. Now with respect to the same person, now all are oriented. With respect to this person, all are oriented left side, right? So again, whatever may be the orientation, the resultant passes through same point, and that point is called as, that point C is called as center of gravity. Why it is center of gravity? Why not center of parallel force? Because these forces are due to what? These forces are due to gravitational effect. Okay, and again in this case I am measuring with respect to my reference point is what? My reference point is inside the body. Okay, I am measuring it from inside the body. So the point through which resultant passes, irrespective of its orientation of the forces which is due to gravitational effect, with respect to the same body. Okay, I am measuring with respect to same body. I am not measuring with respect to some other point. Okay, I am not measuring with respect to some other point. Okay, I am measuring with respect to same body. With respect to same body, position of masses has not changed, but if I rotate it, only the orientation of forces is changing, orientation of gravitational forces is changing, but still the point through which the resultant of those gravitational forces, okay, point through which the resultant of those gravitational forces pass through remains same, and that point is called as center of gravity. Okay, so now finally, what is the definition of center of gravity? Center of gravity is the point through which the resultant of gravitational distribution force, okay, so the resultant of gravitational distribution force, as I said already, it's a force which is due to gravitational effect, okay, will always pass through irrespective of their orientation of the body. Okay, so whatever may be the orientation, the resultant of these gravitational force will always pass through this point, and that point is called as center of gravity. Again, how can I find it? Simple. We already discussed about center of parallel force, right? This is what I got. X bar is equal to summation of xi fi by summation of fi for a discrete system. Integration of x df by integration of df for a continuous system. In this particular case, our f is what? Our fi in general, fi is what? Mi into gi, right? That is mass into acceleration due to gravity. So if I want to write it for a discrete system for center of gravity, this is center of gravity. Okay. If I want to write it for a discrete system, then xi into migi by summation of migi. Wherever fi is there, I am replacing it with migi. And similarly, in place of df, it's going to be dmg. Okay, in place of df, it's going to be dmg. And similarly, denominator also in place of df, dmg. Let me write it fully because this is for x bar, right? Similarly, I can write it for y also. Let me write it now. So now this is the final conclusion which we got. The center of gravity, x center of gravity is equal to summation of x into migi divided by summation of migi. And for y center of gravity for a discrete system, it is summation of y miga by summation of miga, which we already know. In place of force, I am just substituting miga. Okay. Now coming to continuous system, wherever df was there in center of parallel forces, wherever we got df, I need to replace it with dmg, that's it. Integrated, you will be getting. Okay. See, the major thing about this center of gravity concept is this formula you might have known already, but you need to understand the concept. In most of the books which you would have studied, they would have given that, or even I would have used the word in other subjects. The reason for using those words in other subject was, obviously we have not introduced this topic, right? So now I am introducing this topic specifically. So what is that word which I would have used? It is the point about which the total body's weight is concentrated. It is the point about which all body's weight was concentrated. But those are not completely a technical definition. But now you could understand what is the technical definition of center of gravity. It is a point through which resultant of gravitational force always pass through irrespective of its orientation of the body. Whatever may be the orientation, with respect to that body, the resultant will always pass through that point. So now we will understand what is meant by center of mass. Listen carefully. See, generally this g value will be function of x and y. It will be function of space. because we know that in the center of Earth we will be having some gravitational acceleration due to gravity value. In the sea level we will be having some acceleration due to gravity value. As I'm moving up, for example, if you are climbing a mountain, as you climb up the mountain, the acceleration due to gravity will vary, and if you go out of Earth, acceleration due to gravity will vary. Okay, so generally this g value is not constant, it is a function of x and y. But for small bodies, okay, for small bodies, generally small bodies are something which we are dealing with. If you compare it with Earth, the car, the whatever, the house or beams or whatever which you are dealing with, they are small bodies only. Okay, for those small bodies, acceleration due to gravity is not a function of x and y, it is generally a constant. Okay, it is generally constant, it won't vary that much. Okay, the variation will be very less, so we can treat it as a constant. If it is constant, what will happen? Let us see. If it is constant, what will happen to center of gravity first? What is center of gravity in general for what is that, for a discrete system? Xi into mi into gi, right, divided by summation of mi gi. Now as it is constant, all the g's will be same. G1 will be equal to G2 will be equal to, all will be same, which will be equal to G. So since G is same, I can simply take it outside of this, and then I can take it commonly. And if I take it commonly, okay, if I take it commonly outside, what will happen? Simply I can cancel. Okay, so now center of gravity initially represented the distribution of gravitational force, but now it is representing the distribution of mass or distribution of density, because mass is a density, mass is a function of density, right? How it is, we will see. Okay, we know density is equal to mass by volume, so mass is equal to density into volume. Okay, so either this is representing either the distribution of mass or it is representing distribution of density, and this distribution is called as center of mass. Okay, or simply I will just mark it as cm. Okay, center of mass, it is representing what? Distribution of mass or density. Now similarly for what about for continuous system? For continuous system, again, summation of xi, sorry, summation, not summation, integration of x into dmg by integration of dmg. Now since it is we are assuming that for a small body g is constant, I can take g outside commonly, so g integration of x into dm, I can just take this g outside. Okay, so g into dm, I will be getting g into dm. Further, g can be taken outside because g is constant, so I can take it simply outside. So divided by g into integration of dm, which is equal to integration of x dm by integration of dm. Again, this is representing distribution of mass or density, and this is called as center of mass. So if g is constant, our center of gravity, which is nothing but what? It is representing the distribution of gravitational force, that is becoming equal to center of mass, which is nothing but what? Center of mass is what? It is representing the distribution of mass or density. Okay, so it is, both of them are becoming same when g is constant, which is nothing but for small bodies. Similarly for y also you can write, right? So let me write it down. X bar cm is equal to for a discrete, this is what we will be getting. Okay, center of mass x bar cm comma y bar, that will be summation of xi mi by summation of mi, there summation of yi mi by summation of mi, and here it is integration because it is continuous system. Okay, so this is for discrete and this is for continuous. Okay, so finally we will compare it. We will compare the center of gravity and center of mass, and also we will compare we'll compare centroid after understanding centroid now, right? So now let us understand what is meant by centroid. Okay, listen, we know mass is equal to density into volume, because we know that density is equal to mass into volume, right? Mass by volume, right? Density is equal to mass by volume. So since density is equal to mass by volume, I can write mass as density into volume. We already know center of mass is nothing but what? Summation of xi into mi by summation of mi. So in place of mi, I can replace it simply with xi into rho I into vi, where rho I is density and vi is volume, and here summation of again rho I into vi. Suppose I am taking a body, a homogeneous body, where density is same throughout the body. Okay, if density is same, density is constant, then what will happen? Density is constant, right? So rho 1 is equal to rho 2 is equal to rho 3 until all the rows will be same, which is equal to rho. So simply I can take them outside. So if I take them outside, it is rho into summation of xi into vi by, again here also I am taking it rho outside, summation of vi. So it will get cancelled. And what this is representing? What this is representing? Is it representing density distribution or mass distribution? Of course not. It is representing the volume distribution. Volume means what? It's a geometrical property. Okay, volume or even area also. Regarding area, we will talk about it later. As of now, it is volume. Okay, so this is something which is representing volume distribution. It is not representing density distribution, or it is not representing the gravitational force. It is representing the variation or distribution of volume. Okay, so or geometry. Okay, and that is called as centroid. Okay, so we will just write it as x bar CEN. Okay, centroid. So centroid is simply a geometric property. It depends only on geometrical variation, geometrical distribution. So similarly, if I want to write it for what is that? If I want to write it for continuous system, it becomes integration of x into dv by here integration of dv. Okay, so it is just a geometric property. It's a geometric distribution. It depends only on the volume. It is not depend on density. It does not depend on acceleration due to gravity also. So if density is constant, this geometric distribution, that is centroid, and what is this, center of mass, that is mass distribution, both of them are becoming same. So similarly, I hope you could write y also, right? Y bar centroid and y bar centroid you can write. In place of x, you just replace it with y. In place of x, you just replace it with y. Okay. So when listen, when g is constant, okay, when acceleration due to gravity is constant, what we are getting? Center of gravity is equal to center of mass. Okay, that is this is a property which is related to force, gravitational force. So gravitational distribution is becoming equal to mass distribution or density distribution. When it will happen? If g is constant. If rho also constant, okay, in addition to g constant, if rho also becoming constant, then center of gravity, already center of gravity is equal to center of mass because g is constant. Now that is also becoming equal to centroid. Okay, this will happen. That is, all three, center of gravity, center of mass and centroid, will be same one and only if density is constant and also acceleration due to gravity is constant. If only acceleration due to gravity is constant, then center of gravity and center of mass will be same. If both are constant, then all three will be same. I will give you one example for understanding this much better. So let us take this example. Consider buttermilk. I hope everyone knows, right? Everyone know buttermilk. What we will do? We will take curd and we will take water and we will mix it properly so that the curd will get mixed with water properly, so that I will be getting a uniform layer of uniform layer of liquid. Okay, so which we used to drink, okay, during summer season. Okay, most of you know, I hope so. Most of you who belongs to South India know, and I hope so North India also, they will be knowing it. So what I'm doing, I'm taking a buttermilk in a glass. Okay, in a glass. I'm just freshly prepared. Okay, the buttermilk has been freshly prepared. That is, I taken a curd, I taken water, I mixed it properly. Okay, I mixed it properly so that I got a uniform layer of a liquid of buttermilk, and I'm taking it in a glass. Okay, now just observe or just think and say how will be that liquid, how will be buttermilk. curd will be distributed equally everywhere, right? Curd will be distributed equally everywhere. And I'm taking this buttermilk in, you can consider you are just taking it in your home, okay? So the curd was distributed equally, which means there is no density variation or there is no mass concentration. The mass was distributed equally. Okay, so throughout this body, the mass is concentrated equally. The mass is distributed equally, which indirectly density is also distributed equally. And as I'm taking it in my home, there is no issues, there is no problem with the gravitational changes also. Okay, we are assuming gravitation to be constant. So both gravitation G, that is acceleration due to gravity, and density, it is constant. So what will happen? Simply center of gravity and center of mass and centroid, all three will be same, which is nothing but its geometric center. Okay, since G is constant, rho is constant, simply center of gravity, center of mass and centroid, is going to be its geometric center only. That is exactly at the center point of this buttermilk. Geometric center, geometry is what? Cylinder, right? So center of the cylinder, that's it. Okay, so that is going to be somewhere, you can just assume somewhere here. Okay, C, CG, CM and centroid C, all three are same. Why it is happening? Because the density is also constant and acceleration due to gravity is also constant. Okay, so center of gravity, center of mass, centroid, all three are same, and they will be at the geometric center of this particular figure. So if it is a cylinder, so it will be exactly at the center only, center of the cylinder. Now I'm leaving this buttermilk in the table. Okay, so I'm just keeping the buttermilk in the table. I forgot to drink. Okay, I forgot to drink. Consider that I left it and I forgot. Okay, so I'm coming back and I'm seeing after some 10 hours or 12 hours. Okay, so I left it in the morning, I went out and I came back in the evening and I'm seeing it. What would have happened? Everyone knows. Okay, most of you would have experienced it. What will happen? Curd will start settling down. Right, curd will start settling down, and if I keep it in the morning and if I came back in the evening and if I check it, I will be getting something like, okay, I will be getting something like all these curds will get settled down in the bottom, and top region I will be having water. Okay, so curd, let us imagine that these are the curds which is getting settled down. Okay, these are the curds which is getting settled down, and in the top region I am having water, simply water. Okay, so these are the curds which is getting settled down, and we know very clearly mass and density of curd was more. So more denser liquid or more denser more denser element is settled down. So more mass is concentrated at the bottom. And in the top we will be having less mass. What will happen now? What will be the changes which I could observe? Here density is not constant. Here in the top side density was less, bottom density is more. Top in this region mass was less, in this region mass is more. So as the mass distribution changing, as mass is concentrated more in bottom, okay, as mass is concentrated more in bottom, so this center of mass will shift down. Okay, but what will happen to centroid? See, centroid is simply geometric center. Whatever may be the mass, let the density changes, let the acceleration due to gravity changes, whatever, centroid is geometric center, which means I just need to consider it as a cylinder. This is a cylinder. Where is the center? Where is the geometric center? That will be my centroid. So centroid will be always geometric center only. Okay, centroid will be always geometric center only. It's not going to vary the same point. It's not going to vary the same point. But as the mass concentration decrease, as the mass concentration is more in the bottom side, this center of mass, okay, is getting shifted down. Okay, center of mass will get shifted down and it will be here, somewhere here. Okay, let this be center of mass. Now what will happen to center of gravity? See, we are not changing the acceleration due to gravity. Okay, acceleration due to gravity is still constant. If G is still constant, we know if G is constant, what is the condition? Center of mass and center of gravity both are same. So both center of mass and center of gravity will shift down and it will reach a new position here. center of mass and center of gravity. So both center of mass and center of gravity has shifted down. Why it is shifting down? Because more mass concentration in the bottom, that is more density distribution was there in the bottom side, so center of mass and center of gravity is shifted down. Simple. I hope you would have understood. Now further, imagine this is something which we need to imagine only. Imagine this buttermilk glass was very big, okay, very large. It is something like what I could say. This glass height was equivalent to mountain, okay, that much big. So that much, you just imagine it, okay, you just imagine it that this height of this buttermilk glass was very big. So if it is that much big, then what will happen? We know that very clearly, right? If we move towards center of earth, our acceleration due to gravity will increase, and if I keep on moving, as I keep on moving up and up and up and up, acceleration due to gravity will decrease. So more gravity, more gravitational force will be there at the bottom, and less gravitational force will be there at the top. So in this case, density is not constant, density is varying. More density at the bottom, less density at the top. Now in our new case, okay, that is in the final case where I am considering that the container, this glass height was very high. Since the height of the glass is very high, it is hypothetical only. Gravity is also start varying. So more gravitational force at the bottom. G value will be more at the bottom and the G value will be less at the top. So now what will happen? Here G is also not constant. Okay, G is also not constant. G is also varying. How G is distributed? Less G at the top, more G at the bottom. As gravitation effect was more at the bottom, automatically center of gravity will shift further down. Okay, because more concentration of gravity in the bottom, so center of gravity will shift further down. But there won't be any change for centroid. Okay, centroid depends only on the geometry. If it is a cylinder, exactly at the center of the cylinder, geometric center of the cylinder, I will get centroid. As due to variation of mass, okay, due to concentration of more mass here, okay, due to the accumulation of curd at the bottom, center of mass has shifted down earlier, right? And now center of mass will also not vary. Because center of mass depends only on what? It depends only on mass, it depends only on density. So center of mass also will lie the same place only, it will be lying in the same place. But center of gravity will shift further down because there was more acceleration due to gravity at the bottom and less acceleration due to gravity at the top. So G shifted down and it reached somewhere here. Okay, so this is center of gravity, this is center of mass. Okay, so this is something which you need to understand. So in this case, center of gravity, center of mass and centroid all are same. Okay, in this case, center of mass and center of gravity is same. In this case, nothing is same, all three are different. Okay, so that's it. I hope you would have understood the difference between these three. We might use the words interchangeably. Sometimes I will use center of mass, center of gravity. Sometimes I will use centroid. If it is homogeneous body, if density is constant and if acceleration due to gravity is also constant, then all three will be same. So maybe during that time, okay, during this time where density is same, where acceleration due to gravity is also same, then all three will be at the same point. So using the terms interchangeably, not at all a problem. But if density varies, okay, then using the terms interchangeably will be a problem because centroid is different. Now center of mass and center of gravity is different. If G also varies, then all three will be different. Okay, so the final conclusion or the final formulas which we are going to get, okay, center of gravity, so that is going to be x bar cg, right? X bar cg. I'm just writing only for x bar, you can write it for y bar also, and this is x bar cm. Okay, this is x bar centroid. Okay, so here for center of mass, G is constant, and here for centroid, density is also constant. Okay, so simply x into mi by mi, so here summation of x into vi by vi, and there it is continuous distribution, so I will be using integration, continuous, so I will be using integration. Now for a property based, the first one, center of gravity is representing gravitational force distribution, and center of mass is representing mass or density distribution, and last but not the least, centroid is representing geometrical distribution. Okay, so I hope it is clear now.